speaker is Alexander. So, 3 minutes. If you see something you like which is good, copy it. So lots of movement, etc. If you see things you don't like, don't copy it. Good. 3, 2, 1, go.
Hi, my name is Alexander Daykin, Iliopoulos, and today I'm talking about my PhD, which is in spacecraft propulsion in collaboration with the Japanese Space Agency. So first of all, let me just say that spacecraft sizes are ever increasing with the demand for telecommunication payloads to scientific payloads, let alone the type of demand on the spacecraft that we require for such missions like the manned mission to Mars that's planned for 2030. So what I'm looking at is spacecraft propulsion that are larger and last longer to move such masses in orbit. So the particular device that I'm working on is called a hollow cathode. This device emits electrons. It's used in conjunction with another propulsion system, such as an ion engine. The ion engine emits ions which propel the spacecraft forwards, though these ions are positively charged. So when you emit many of these ions, you get a charge build-up, and the ions will end up going back to the spacecraft. Hence, what you do is have the hollow cathode, which emits electrons. Electrons are negatively charged, so this neutralizes that effect. So how does the hollow cathode work? Well, you have the red insert shown there that's heated to fermionic emission temperatures. Now what does that mean? It's just like a kettle at home. You heat up the water and it boils. Well, you heat up this insert and the electrons get enough energy that they break free from the atoms and they are emitted. Then xenon propellant is injected into the system and it collides with these electrons and it's ionized. At this point, this results in more electrons being emitted. You can see the electrons being emitted in the top right corner there. Now we understand how the hollow cathode works, I want to explain about what I'm doing. I'm trying to make the hollow cathode last longer so we can make the mission to Mars possible. So one of the components of the hollow cathode is the heater. Now this is unreliable because it firmly cycles from 0 to 1,500 degrees. This causes thermal fatigue and fracturing, rendering the hollow cathode useless. So what I'm doing is removing the heater from the heater component from the hollow cathode, and I am changing the geometry inside the hollow cathode to make it sharper, using the same technology that you have on a lightning rod on top of a skyscraper. Then you get the lightning bolt, it creates a tremendous heat. I'm using a smaller discharge, but the same idea inside the hollow cathode. This discharge will self-heat the insert to the fermionic emission temperatures. What this does is, this will make the hollow cathode more reliable, will last longer, and hopefully this will allow man to reach Mars in 2030. Thank you for your time.